This is my AP Calculus AB final project exam for Miss Bond. I'm Ezra Braig, and I hope you enjoy it. Alright, this is my Calculus Integration Volume by Rotating an Area project. There's our function you see over there, bounded by y equals x squared, y equals 5, and x equals 0, being rotated about the x-axis. Basically, this whole video is about me showing you how you would be able to complete a problem like this one. So first, what you want to do is you want to take a little, what's called a slice, from the area inside our function. What we're going to try and find here is dv, in other words dy. It's like the width of our slice. And here I'm going to draw our slice really quick. There we go. So we're trying to find the area of our slice, so we can multiply that slice multiple times in our function, so we can find the ultimate end volume of our function that's being rotated over the y-axis. But we know the area is going to be pi r squared, as you can see there. Sorry, and dy is our width again. Our radius of our slice is basically going to be equal to x, because at any point, if we were to take a slice lower down on the function or higher up on the function, the radius would be constantly correlating to the x and whatever we plugged in for x. So we can basically just say dv equals area times dy. In other words, pi r squared times dy. And there you see r equals x. And since we're only using one x, we don't want to get it confused with any others. We're just going to make that x1. Pi r squared, or pi x squared, because r is always going to correlate to x, dy. And now, basically, I'm just going to show you what you would, in theory, do. You would take all those little slices, minusculely small, and multiply them, their areas, by each other to find the volume of our function. But we don't have to do that. We're just going to make an integral for the total volume, which we will call v. Our integral is going to be from 0 to 5 times dv. So, in other words, our integral is going to be from 0 to 5 times pi x squared dy. Just watch me as I write this. We're then going to set that into an absolute value integral, where pi is going to be on the outside of our integral. So it's going to look like the integral from 0 to 5 times pi y dy. We next then have to put that into an equation that's going to be pi y squared over 2 the absolute value of 0 to 5. And what that looks like in an equation is pi times 5 squared over 2, which minus 0, because it's the absolute value integral, which is going to equal 25 pi over 2. And that is our answer.